All right, guys. Well, I'm sorry to be absent again. However, nothing I can do about it. So, what I wanted to do was go over a few of the things you learned yesterday and then also teach a few of the problems in today's lesson. Just like yesterday, the full notes keys are available in Schoology, so you can pull those up. But I know it's really hard to learn from just looking at the finished product. So, the first thing that you see over here on the right side of my screen, this is the iPad or phone version of the calculator, and you can get this in self-service. It is called Calculate 84. So if you search that up in self-service, you can find that. And I just did split screen so that I could have it on my screen while I was doing my work. Now you can't use this during a test or a quiz, but it has all of the same functionality as the graphing calculators. So if you don't have a graphing calculator, you can use this for while we're practicing in class and for your homework, and then that way when we get to our test or quizzes, you can go ahead and you'll know how to use the calculator. So the first thing that you guys worked on yesterday was just going ahead and just, straight up plugging these things in the calculator. And so basically, E is another number. It's an irrational number, kind of like how pi is an irrational number that you learned about back in geometry. And for right now, you don't really have to understand what it is or why it's used. We don't really need to get into all of that right now, but we just want you to understand that it is, in fact, an irrational number. And with this irrational number, it has its own special log. And so when you happen to have a log that is base E, we actually simplify that and call it a natural log, which is abbreviated ln. And when I write ln, I usually use a cursive L just so that it doesn't look like a 1. Now we learned earlier in the chapter that if you were to have something like, for example, 5 log base 5 of x, we learned that these would go ahead and cancel. Remember learning that earlier in the chapter? Well, the same thing is true here. The difference is that when you see ln, you don't usually see the e because it's not written. Just like how when you see a log without any number, we know it's base 10. Well, when you see an ln without any number, we know it is base e. So in these two problems here, there's this little e right there. That's a terrible e. And here there's this little e right there. That one's a little bit better. And these will cross off, just leaving us with x. And these will cross off, just leaving us with x. And so this is showing us how that property of inverses that we learned about earlier still applies. Now, these first couple problems were putting these ones right here. We're just entering these in the calculator. And when you're looking on the calculator and you're trying to find where the buttons are, the ln button is right here. It is above or in between the 4 and the 7 on the left. And the e to the x is right above the ln. So if you see, there's the ln button right here, and then there's the e to the x right above it. And since e to the x is in blue, in order to get e to the x, we have to press the second button. So if I wanted to type in, for example, this one right here, number 2, I would say second ln, and now I can see up on the calculator screen the e, and then I would do negative 0.5. Oops, looks like I did a double negative. Got a little too excited with that button pushing. Negative 0.5, and then enter, and then I can see my answer. And just like with the regular graphers, the answers will stay on the screen. If I wanted to do just an ln, so let's say I was doing this problem here, ln of 12, I would just press ln, and then 12, and then enter. All right, now for if we move on to the second page was talking about solving. And when we're solving base E equations, basically what these directions say is that if you happen to have a problem that has an E in it, then instead of just doing a regular log, we want to do a natural log because that has that ln base E, so they'll wipe out, all right? And if the equation starts with a natural log, then you want to e both sides, which sounds really strange. You want to take both sides and raise it up so that it's in the exponent with e as the base. So I'm just going to do one of each of these, and then we'll move on to the lesson for today. So if we were to look at number 1, for example, in this problem, I would want to get that e to the x by itself. So I would first add 5 to both sides, giving me 2 e to the x equals 6. And then I would divide by 2, giving me e to the x equals 3. And now at this point, now that I have the e to the x by itself, this is when I'm going to ln both sides. And I'm just going to scooch that over. So I'll ln here. And then I'll say, oh, hey, what do you know? I know that these are inverses, so they cancel off. So that means that x equals ln of 3. And like we talked about the other day, we have the exact answer and we have the rounded answer. So this is my exact answer. And then when I want to get my rounded answer, I go to the calculator. So ln of 3, enter. And I want to do 4 decimal places, so 1.098. And then I see a 6-1, so the 1 tells me I don't round up, and that would be my rounded answer. All right, I'm going to go ahead now and do number 4, because number 4 has an ln problem. So when we look at number 4, in this case, we want to get the ln by itself, which it already is. So it is ready for me to e both sides, which again, I know sounds so strange. So I'm going to raise this up. And after I do that, this e and ln cancel, leaving me with 5x equals e to the 4th. And then I want to finish getting x by itself. So I do that by dividing by 5. So I divide by 5, leaving me with x equals e to the 4th, all divided by 5. Again, this is my exact answer. And then when I want to put that in the calculator, so to get e, I have to do second ln. So I'll do second ln to get e. I raise it to the power of 4. And then now I'm going to use the right arrow so that I'm no longer in the exponent. So if you look at my calculator, I know it's kind of hard to see. When I was up here, I'm up in the exponent. If I did divided by right now, you see how I'm still up in the exponent? That's not good. I don't want that. I want to actually not be in the exponent. So I'm going to hit the right arrow, and then I can do divided by 5. And then that will give me my correct answer of 10.916. 9196, yes, because the 3 tells me that I want to stay and not round up. All right, so that would be my exact or my rounded answer. All right, so this is what you guys learned yesterday on your own. And like I said, I know that it's hard trying to learn notes just from looking at the notes key, and for that I apologize. I was so sick yesterday, there was no way I could even make a video. I didn't even get out of bed until 2:30, so I apologize. Trust me, I would have rather been with you guys. All right, so for this day 2, I'm just going to jump on in with some of the examples. And again, right here, we're just reminding you of these properties. So when we have two separate logs, these here can be combined into one with multiplication. Two separate logs being subtracted are combined through division. And when we have that coefficient in front, it turns into an exponent. So for all of these, this is essentially the same as what we were doing yesterday. We just have that extra first step. So first, we need to condense. And then after we condense, we are going to either ln both sides or e both sides. And it just depends on what kind of problem it is. So we'll do a couple of these to help you see the difference. So let's go ahead and I'm going to pick some of the harder ones just so we can get some variety in here. So let's take a look at number 3, since number 3 has a lot going on. So if we look at number 3, we're going to notice that first we have these exponents or coefficients that turn into exponents. So this will give me ln of x squared plus ln of 2 to the 3rd equals 5. And then since I know that 2 to the 3rd is 8, I can just replace that with 8. And because here I have a plus sign, that means I'm multiplying those. So this will give me ln of, and like we just said, this is equal to 8. So I'm just going to say ln of 8x squared equals 5. And then since this problem is an ln problem, I can get rid of ln by doing its inverse, which is e. So I'm going to e both sides. And then this will cancel off, and we'll have 8x squared equals e to the 5th. And then from here, we want to finish solving for x. So this is like stuff you did first semester. We're going to divide both sides by 8, and then we get x squared equals e to the 5th divided by 8, and we are almost there. our final step is that we need to square root. So then we will get our exact answer will be that x equals. And then when we start out by writing our answer, we would normally have a plus or minus of the square root of e to the 5th over 8. And recall we've talked about that you can't put a negative value inside of a log or an ln. So we have to look back at the original problem. And if we look at the original problem right here, if I were to plug a negative number in right here, that would not work for me. So in this case, I cannot have the negative. So it's just simply the positive of it. And so that would be my exact answer. And then when I go to type this in the calculator to get my rounded answer, to get my square root is going to be right here. It is above the x squared. So since a lot of these calculators, when you're looking for the function, if you don't see it, look for its inverse operation. So a square root is the inverse of x squared, so it's above the x squared. So to get to that option above it, I have to do second x squared. So that gives me my square root. And then I want to open up parentheses. Now, on a lot of graphers, the square root button will already open up parentheses. This one didn't, so that's why we needed to open them up. So then we'll say e to the 5th, so second ln to get my e to the 5th power. I'm going to use my right arrow so that I'm no longer up in the exponent, divided by 8. So what this is going to do is this will find e to the 5th power, it'll divide it by 8, and then it will square root the answer. And then that is how I will get my exact answer of 4.307. And then in this case, I do need to round because that 5th digit is 5 or higher. All right, so now let's take a look at a problem involving, oh, these are all ln's. Huh, okay, cool. All right, let's take a look at one that has subtraction. So how about we do, let me look at the key real quick and see which one looks harder. All right, we'll do 5 and 6, and then we should be good to go. All right, so for number 5, if we went ahead and did this one, and if at any time you need our sub to pause the video or go back, to speak up and say something. So here we have a subtraction problem, so subtraction is going to combine with division. So we'll say ln of x divided by x plus 4 equals ln of 2. And then, hey, check this out. We have an ln on both sides. When that happens, we can just say x over x plus 4 equals 2. Those are my favorite kind of problems. We don't have to do any of the extra hard work. So now we get down to this. And then here, we can just cross multiply. So we'll have x equals 2x plus 4. Don't forget those parentheses. And so we'll distribute, and we'll solve for x. So if we minus the 2x over, we get negative x equals 8. So x equals negative 8. All right, just like always, when we get our answers, we have to check it back in the original problem. And oh snap, that's going to give us some issues. That negative 8 will not work. Okay, so since ln of negative 8 is not valid, that basically means there is no solution to this problem. So for that, you can either write no solution or you can do the no solution symbol. Okay, let's look at our last example. We'll do number 5, and then we'll be done, and you guys can get started on your homework. All right, so here we're going to do the same thing. We want to combine our ln's, so we're going to combine them with, in this case, multiplication. So we'll have ln of x, parentheses, x minus 2, equals ln of 24. And whoa, check that out. Ln equals ln. We can get rid of the ln's. So we're just going to have x squared minus 2x equals 24. And then remember, at this point, we have a quadratic. Whenever you have a quadratic, you have to set it equal to 0, factor solve. So we'll have x squared minus 2x minus 24 equals 0. And this is where we do the little x. And we're looking for numbers that multiply to make negative 24, add to make negative 2, and that would give us negative 6 and 4. So we have x minus 6, x plus 4. which tells me that x equals 6 and -4. And once again, we go back up to the problem. Are either of these answers things that could not plug back in? And hopefully you're looking at that and you're saying, ugh, we can't use that -4. We're going to cross that out. And my only answer here is x equals 6. All right, guys. I know this is not ideal. I really hope that I can come back to work tomorrow. I miss you guys. Trust me. I do not like being sick. It is no fun. So keep smiling. Keep working hard. Be nice to our sub. If you still happen to have Mr. Yates, fun fact, he was a student of mine. Oh, yes, he was. So be nice to him. All right. Have a great day, everybody.